All right, ladies and gentlemen, thank you guys for all having some note paper out and being ready. If you're not ready yet, go ahead and get ready. Thank you, Mr. Zakalik, for putting on this video for my students. So we have been approaching the sine and cosine function in a very interesting way that's a little more conceptual than the way pre-calc has been taught in the past. We are an Algebra 2 class, but we are actually working on some pre-calc. All right, so please get out paper and we are going to take some notes. The title of your notes could be Period of a Sine and Cosine Function. Our goal is by the end of class, every student will be able to identify the period of the sine and cosine functions. And not just, oh, the period of sine is 2 pi, but what if we change the period? So really what that is a horizontal dilation. So our first agenda item is to define the period. We're going to identify the period from the equation, so given an equation, and then we're going to graph with different periods. Tonight's homework is number 12. All right, so quick activator. We did this 2 days ago when we graphed the sine theta. So what I want you to do is go ahead and graph it again and decide, what do you think, if a period is the amount of duration for one complete cycle, what is the period going to be? So take a second, graph just what is the sine curve and what would one period be. So there were some people that were out at outdoor ed, so I might just do a quick little recap. So here we have a height of 0, right? So at 0 degrees we're at 0. At pi over 2 degrees, the height on the unit circle, this height would be 1. So if after pi over 2 radians have passed, we're at the height of 1. After pi radians, we are back at 0, this height of 0. And then when we're down here at 3 pi over 2, we're actually down 1 below at negative 1. And then if we keep going back to 2 pi, we have one full cycle of sine. And I feel like some of you may have even known this before we graphed it. So one full cycle of sine would be from here to here, and then it starts again, right? So then there's another sine period. So we call this the period. And the period of sine is 2 pi. Now, we could also say it's 360 if we were talking about degrees. All right, before we move any further, actually I'm going to insert a page, and let's remember what we were talking about with the Ferris wheel. So the Ferris wheel, the center of the Ferris wheel was 30, I can't remember if it was meters or feet. I'm just going to say feet. 30 feet off the ground. Okay, the center of the Ferris wheel. And then the radius was 25. I'm going to run out of room here, but the radius, right, was 25 feet. Okay, and then it took us 20 seconds to get around one full cycle of the Ferris wheel. So when we wrote the equation for the height with respect to time, we went 30, right? That was our not amplitude, our midline, right? Our center, plus 25, that was the radius, sine of something t. And what we put in here was we took 360 degrees and we divided it by 20 seconds because we were going to get all the way around our circle back to the beginning in 20 seconds. So I wanted to know how many degrees per second. And you guys got really good at this. So if I divide that, we would be going at a rate of 18 degrees per second. So our equation would be 18t right there. Now this is going to be really important. This actually helps us determine what our period is. So I just want you to keep this in mind. If I have 18 degrees per second and I multiply by the number of seconds, my seconds, the units, cancel out. And what I'm left with is just an angle measure. So if I'm taking the sine of something, really what I'm taking it of is an angle measure, right? The sine of 18 degrees. So this is our rate, 18 degrees per second, and that's our seconds. So the seconds will cancel out. All right, I just wanted to do that kind of as a, to trigger some of those neurons of things we've done in the past. Okay, so now we have this problem. If we go around the unit circle counterclockwise, 1 revolution in 4 seconds, we want to know what would be the period in terms of time. Well, it just said 1 full cycle in 4 seconds, so our period is 4 seconds. If it takes us 4 seconds to get around, then that is our period, 4 seconds. Now that is not going to be the number in our equation that we use, so we need to do something to it before we figure out our rate. Okay, so what would be the angle per second in radians? So how many radians per second? Well, a minute ago we did 360 degrees divided by the number of seconds, but now we're talking about radians. So really what we want to do is 2 pi divided by, and in this case, 4 seconds. All right, so the radians per second, this simplifies and we get pi over 2 radians per second. And if you think about it, it makes complete sense. If I have 4 seconds to get around this whole circle, 1 second, 2 seconds, 3 seconds, 4 seconds. It makes sense. Pi over 2 radians for every 1 second. All right, so now we need to write the sine equation in terms of time. So the sine equation, if it says equation, I better have an equal sign. So let's say h of t in terms of time is equal to, let's see, all that we have adjusted is this 4 seconds. So we're going to have sine, and we figured out this was our rate, so we're going to put pi over 2 times time. This is radians per second times the number of seconds. So the seconds cancel out, and we end up with just an angle measure. All right, so that would be our equation. If we have to graph this equation for one period, well, our midline didn't shift. We're not going up or down. Our amplitude didn't shift. We still have an amplitude of 1, but our period is adjusted, right? So we have 1, 2, 3, 4. 4 seconds. And this is our time. And we might want to even say in seconds. And this is our height based on our time. I like to put some little bumpers up here at 1. Kind of give myself some limits where I'm headed, and -1. And we know that sine is going to always start at the midline. After 1 second, we're at the highest point. Remember, we're starting here and we're headed counterclockwise, so then we're going to the highest point, then back to the mid, then to the lowest point, and then back to the midline. So one period of sine would be like that. That made 1 revolution in 4 seconds, and the equation would be this. All right, let's try another. The first one's always a little bit scary maybe, but maybe not. You guys are really good at this. Okay, what if we go around the unit circle again, counterclockwise, 1 revolution in 36 seconds. So how is that going to change things? We're going in 36 seconds. First it's asking, what is the period? Well, you just said it, the period. It takes 36 seconds to get all the way around the circle. Seconds. So that is my period. All right, what would be the angles per second in radians? So radians, 2 pi over 36, simplify, and we get pi over 18. And this is radians per second. All right, so then it says, write the sine equation in terms of time. Write the sine equation in terms of time. So we want to write our equation, maybe f of t, or h of t, like I wrote last time, is equal to sine of this pi over 18 times time, right? That's our kind of our rate. All right, and then we need to graph it. So we haven't changed, our midline hasn't changed, our amplitude hasn't changed, we still have amplitude of 1, but our period is now 36 seconds. So if I have there's always 4 quarters, right? There's always 4 parts, 4 quadrants in our unit circle. So if I have to take one full period, 36 seconds, and divide it into 4 pieces, each piece should be 9 seconds. Well, that's really important for when I'm making my x scale or my time scale. So every 9 seconds, 9, 18, 27, 36. I broke that up into 1, 2, 3, 4 chunks. So why is that important? Well, we basically have 5 points we want to plot. We're going to go up 1 and we're going to go down 1. I guess I'll give us a little guide here. All right, so in 36 seconds, we need to complete one full cycle. It's a sine function, so I'm going to start at the midline. We start going counterclockwise, right? So we're headed this way. Our height here is 1 after 9 seconds. We're 1 higher than we were 9 seconds ago. All right, after 9 more seconds, we're back here. And then after 9 more seconds, we're here. And after 9 more seconds, we're there. So our sine curve would look like this. And it's with respect to time. So 36 seconds is what it took to make one full cycle. All right, wonderful. Let's do some other ones. These are a little bit trickier. The next 4 that we're going to try. We're going to do 2 together, and then we'll see if you can try a couple on your own. So it's a little trickier because our numbering here is going to be in radians and not numbers. Okay, so here is an equation. It says, here's your equation. Sine of 2t equals f of t. All right, and we need to know what the period is. So previously, we said, okay, let me take 2 pi and divide it by the number of seconds, and that will equal, that was the period, right? The number of seconds right there, that was the period. And that gave us this number that we put right here. And in pre-calculus, we call it b. So I'm going to call it b. So the formula here, I guess, would be 2 pi divided by the period gives you the b value that goes right here. That's really the horizontal dilation. So it's asking, what is the period? Well, if we know that the b value, we already know b. b is 2. So we have to say, well, 2 pi divided by some number, question mark, I'll put x, is equal to 2. Right? That's the number, the radians per second that we put in there. All right. Now something happens here. To get to 2, my pi has to simplify out. Well, in order for that to simplify out, we have to have it be pi. And we can just look at it. Some of us can just look at it and see, oh, it must be that. But others, we might actually want to do some math. So here we would go times x, that cancels, times x. 2x equals 2 pi. Maybe now you see it. So these cancel out, right? You might see it now and say, oh, 2 times x, 2 times pi, x must be pi. If you don't see it yet, keep going, divide by 2, and pi equals x. All right, so what we just found is that our period is pi. Okay, so the graph of this sine function, sine of 2t, is only going to be pi units long. Normally, sine function is 2 pi units long. So we went 0, pi over 2, pi, 3 pi over 2, 2 pi. That was from 0 to 2 pi. But now, we are going to have one full cycle in pi units. So our horizontal dilation is like if this was a spring, we're squishing the spring back together. All right, so let's go ahead and graph that. I'm going to erase some of this so I have room. All right, so our period is pi. Okay, so let's go ahead and put our axes out. This is our, what variable? T, and this is our f of t. Okay, so I need to take my period and chop it into 4 pieces. So if I take pi and divide it into 4 pieces, well, it's pi over 4. So each chunk, each step of this function needs to be pi over 4 units. So that's 1 pi over 4. If I go here, it'd be 2 pi over 4, but 2 and 4 simplify to pi over 2. So 1 pi over 4, 2 pi over 4. This would be 3 pi over 4. One more step would be 4 pi over 4, but that'd be kind of silly to write 4 pi over 4 because it's just pi. Alright, so that is going to be my scale. Now, it looks like our amplitude is still 1. So we're going 1 up and 1 down. And sine is going to start at the midline. Let me get my little borders in here so I can... Alright, so it starts at the midline, then it goes up, then it goes back to the midline, then it goes back down, then it comes back to the midline. Alright, so here's my sine function. From 0 to pi, alright, that would be my graph. So the key thing here is that once we find our period, that we cut it into 4 parts and count by those parts to figure out all of our spacing for our x-axis. All right, we have about 3 more of these. Okay, I'm going to help you find the period, and then I want you guys to try to graph this on your own. So we're going to hit pause, you're going to try it, and then you'll get some feedback. Okay? All right, so for this one, we have sine of. I'd like to rewrite this a little differently. I'd like to write this 1/2 t. So t divided by 2, t over 2, is equal to 1/2 times t. I think that helps me see what's happening better. It helps me find my b value. All right. So, what is the period? Okay, so we are going to take 2 pi divided by the period is going to give us that b value. Well, we know what b is. B is 1/2. 2 pi over p equals 1/2. Now we could just do, I'm blanking on the word. What is this called? You guys are probably saying it right now. Cross multiply. There we go. We could cross multiply. 2 times 2 pi would be 4 pi. And then 1 times p is 1p. And we're trying to find what p is. Well, we just found it. P is 4 pi. Wonderful. My period is 4 pi units long. So first question, what is the period? 4 pi units. Or 4 pi radians. Okay? Let me go ahead and just move this over. Okay. So now we are needing to graph it, and you guys are going to graph this on your own. Be careful before you graph. You want to make sure you have your quadrants and you're ready to go. Okay, go ahead and hit pause, try graphing this, see what you get, and then we'll check in on the answer. All right, so this is what I got. Double check and make sure that's what you got. If you have questions, please raise your hand, ask Mr. Zakalik, or any of our wonderful paraeducators. All right. Next question. What do we got here? So it says, what is the period of this? What is the period of this? Well, this is cosine. And cosine, when we graphed it, we started, right, we were talking about the shadow, right, the shadow on the Ferris wheel. We started at the furthest distance away, so we started at the furthest distance positive, and then we went to 0, and then we were at negative distance away, right? And then we were back to 0, and then we were back to positive. And that all occurred in 2 pi radians. So our cosine period is exactly the same as our sine period, and that would be 2 pi. All right, so now, ooh, look, we have to add some exciting stuff here. Okay, so we have two adjustments that need to happen. We need to adjust, what does this 2 do to our graph? Exactly, I heard someone say it changes the amplitude. Good job, you guys are so smart. All right. So we need to figure out what is, it says graph it for a period. Well, what is a period? So we have to figure out if this is our b value, right? 2 pi divided by b. So our period, did I just do that wrong? I just did that wrong. It kind of ends up being the same thing, but I should do it right. Okay. Well, should I just show you? Okay. So here's the equation. 2 pi over p equals b, right? But if we solve this for p, I would multiply both sides times p, so I'd have 2 pi b equals bp, but then I divide both sides by b, then I get the equation 2 pi over b equals p. Huh. So this equation and this equation, so if you know p, you can find b, and if you know b, you can find p. Okay, all right. So maybe this way is a little easier, and maybe Mr. Zaklik has already shown you that, but yeah, so let's go ahead and do that, because that'll be even easier. So we're going to take 2 pi and divide it by b to find our period. So 2 pi divided by 4, oops, and all right, sorry, I'm recording this on Thursday afternoon. All right, so 2 pi divided by 4, this simplifies and we get pi over 2. So our period is pi over 2. Oh, wow, period is pi over 2. Okay, this is important. Period is pi over 2. And then 2 is our amplitude. So let's start thinking about this. Amplitude is 2. We didn't shift up or down. We had no vertical translation, but we have up 2 and down 2, right? That's our amplitude. So our min and max are positive 2 and negative 2. Okay, but if my period is pi over 2, we were taking our period and dividing it into 4 sections. Now, I'm taking this section right here, pi over 2, that's all we're using, and we're cutting it into 4 sections. So cut it in half, and we're at pi over 4. So this is pi over 2. Cut in half, we're at pi over 4. If I cut those in half, what are we at? We are talking about eighths of pi. So 1/8 of pi, 2/8 of pi, 3/8 of pi, and 4/8 of pi. Whew, which some of those simplify. So we're going to label this axis as eighths of pi. All right, so here we have 1 pi over 8. Here we have 2 pi over 8, but that simplifies to pi over 4. Here we have 3 pi over 8. And here we have 4 pi over 8, but that simplifies to pi over 2, which is perfect because my period is pi over 2, therefore I should end one full cycle at pi over 2. We also want to include 0. All right, so this is a cosine function. Uh-oh, I just realized there's an extra t in there. That was a typo. It shouldn't say cost. It should say cosine. Oh, you guys might have already figured that out. Okay. So, cosine function, we are going to start at the maximum value because we're looking at the width here. And then pi over 8 units later, we will be at the midline. And then we will be here. And then we will be here. And then we will be here again. So one full cycle occurs in pi over 2 units. I'm sorry, pi over 2 radians. All right, so we want to label our axes. This would be t, and this would be, in this case, g of t. Wonderful. We have one more, and that is all of the notes we have. If you finish early, either Mr. Zaklik can come up with some more practice examples for you guys to try to find the period for, or you can get started on your homework. All right. So one more problem. I'd like you guys to try it. So I'm going to ask you guys to pause it, try it on your own, and then when you hit play, the answer will pop up. Okay, go ahead and pause it. Thank you. All right. This is the graph that I came up with. My 1/4, I took 2 pi and divided by 1/4, which I multiplied by the reciprocal to get 8 pi as my period. Then I took that period, divided it into 4 chunks. Why did I divide it into 4 chunks? Ah, yes, because there are 4 quadrants in the unit circle. Sorry. Okay, so I found that each section, each quadrant, we're going to use 2 pi radians in that same movement. So 2 pi radians, 2 pi, 2 pi, 2 pi, to make one full cycle in 8 pi radians. All right. Wonderful. Thank you guys for watching the video and being so kind to your substitute. Have a wonderful weekend. You want to make sure to get the homework and do some extra practice if you have time. Thank you for watching. All right. Have a great weekend. Bye.